Hello, Dr. Ron Eaglin here, and I'm going to take you through the concept of an iterative solution by hand. So let's first start with the concept of an iterative solution. Well, suppose you've got an equation that's a relatively complex set of equations, or a function that's complex. For example, this function trapezoidal q, and it takes in a number of inputs n, b, y, z, s, n being, in this case, it's the function for using the Manning's equation, but it takes in a number of inputs and it calculates an output with those inputs. That is actually the only part that's important about this, that it's got a number of inputs, that it calculates an output, and then that output is then returned. So in the case of the define of this function trapezoidal q, down here return q, that's what it does. But it does it with these inputs. So to start with, I'm actually just going to put this in memory. So I'm going to highlight it and control enter it. So now that's actually in memory. This function now exists in memory in Python. Now, what I want to do here, though, is I want to know the value of y, which is one of the inputs, which gives a specific output for q. So in this case, y is depth and q is flow. And suppose I know the flow is 500. So I'm going to make a note here. I want to know depth if flow is equal to 500. And flow being Q. Okay? So flow is Q. I'll put Q right there. Now, what can I do? Well, if I know the other parameters, let's say those parameters, the numbers that I've got there, 0.022, 32, and 0.01 for N, B, Z, and S, I can go ahead and put those into memory. So those values, now if I go over to Variable Explorer, you can see those. And now I'm going to go ahead and calculate the flow. But notice if I do the calculation here, Q equals trapezoidal Q, I'm going to call the function. I'm going to call it first with a value of 1. All right, so what has happened here is I've got an output. I can go up into my Variable Explorer and I can see that at y equals 1, q is equal to 25.9. Well, I'm looking for 500. So 1 is obviously too small of a guess for the y, which is, by the way, the depth of flow in the channel. So let's make it much bigger. Let's go with 5. Now if I highlight this and run it again, it's going to do the same thing with 5. Well, if you noticed, Q is now 824. 5 is obviously too big of a guess. So I know it's greater than 1. I know it's less than 5. Now, in a computer sense, I would probably say, well, between 1 and 5, what's halfway between 1 and 5? Well, it's 3. So let's guess with a 3. So now if I run this again with the 3, I get 254. Well, again, now I know it's between 3 and 5. So let's guess again with 4. And now I've got 489. I know I'm close. Remember, I'm looking for 500. Between 4 and 5, I've got 489. Let's go. And now let's make this 4.5. Okay, it's probably going to come up a little high. 643. So being intelligent, I could just keep splitting the difference, but you know what? I'm going to now go try to see if I can nail it down. So let's go to 4.1. 4.1 is 518. And as you can see, what I can do is I can just keep guessing and then run that line over and over again until I get to the right answer. Now, with 4.05, I'm really close, 504. So let's just do 4.055. Let's go just a little bit more. Oh, wait, 4.055 would be wrong. I'm going in the wrong direction. I'd do 4.045 because we're going to go down a little bit. And now I'm at 502. As you can see, I'm getting even closer. But essentially, I can now iterate in on that solution. Now, the thing is I don't want to sit here and keep guessing these guys by hand. That just is a lengthy process. So if you look at my other video on iterative solutions, you can see that I can write a routine that actually methodically nails down the answer of this. And if you are following along and you want to know what 500 is the right answer,